Recitation 8. So it's trig functions. So let's see, we have this big circle. We need to fill in the blanks. Let's do the first half, the first quadrant and the second quadrant. So first, let's see how we measure our angle. We measure our angle starting from the positive side of x-axis. I go this way. That's a positive angle. If we go this way, that's a negative angle. All right, so positive, keep going, keep going, keep going, keep going until here, until the y-axis. So this is a 90 degree. Oh, we have here 90 degree. Or in radian form, that's pi over 2. How do we get it from 90 to pi over 2? We use this relation. We use a 180 degree equals to pi. And we can rewrite this. We can rewrite it as 180 degree divided by pi equals to pi divided by 180 degree equals to 1. Okay, pi has a radian form, so usually we call pi rad. We use this. So if you want to change the angles to radian, so we multiply by pi over 180 degree. Right, this 90 is the numerator, this 180 degree is the denominator. So here we see degree cancel degree, 0 cancel 0, 9 go to 18 2 times. So that's how we get a pi over 2 rad. Pi over 2 rad. All right. Then if you keep going until we make a straight line. One straight line is 180 degree. 180 degree right here. Or just pi, because 180 degree equals to pi rad, radian. If you keep going until here, that's 270 degree, which is a 3 pi over 2. Then we keep going until come back here to positive x-axis. That's a 360 degree. So 360 degree is the same as 0 degree, right? In degree form in this case. And it's a 2 pi. Because 1 pi is 180 degree. So 2 pi is 360 degree. So we need to remember the correspondence radian form with the degree form. So 30 degree equals to pi over 6. Because 30 goes into 186 times. 45 degree is pi over 4. And 60 degree is pi over 3. 90 degree is pi over 2. 120 degree, well, we could do this. We do 120 degree multiplied by pi over 180 degree. Degree canceled, 0 canceled. So that's divided by 2. So I have, let's divide by 6. So 2 times 6, 12. 3 times 6, 18. So 2 pi over 3. Okay. Then 135, we could do the same thing, right? 135 times pi over 180. Both of them can be divided by 5. Divided by 5, we have 27 degree, right? A normal degree, because we can cancel the degree. If divided by 5, we get a 30, 15, 5, 30, so 180 divided by 5, we get 36, right? 36 can be divided by, so 27, 36, both can be divided by 9. So 3 times 9, 27, 4 times 9, 36. So we have 3 pi over 4. Okay. And then this one you can calculate, you should get 5 pi over 6. So on and so forth. You should do this conversion, okay? Now let's look at the points. So this point, x value is 1. And basically we see this unit circle, right? Radius 1. So this is circle outside. We call unit circle. We have an equation to represent that. So x squared plus y squared equals to 1. Okay, so this one, this point, the x value is 1, y value is 0. Right, 1 squared plus 0 squared is 1. And this one, sine 30 has a beautiful value. So the first one is cosine value. The second one is a sine value. Let's come back to this point again. So cosine 0 is 1. So x value equals to cosine of the angle. In this case, is cosine 0. Cosine 0 is 1. And this value is a y value. It's a sine value. Sine 0 is 0. Right. So for 30, the first one is a cosine 30 degree. And the second one is a sine 30 degree. Well, sine 30 is a half. And cosine 30 is a square root of 3 over 2. Then pi over 4, so the first one is cosine pi over 4, or cosine 45 degree, which is square root 2 over 2. The same cosine 45 is the same as sine 45. So those two values are the same. Then here we have cosine pi over 3, cosine pi over 3, or cosine 60 is the same as the sine pi over 6, because this is the cofunction. Because 30 degree, 4 pi over 6, and 60 degree, 4 pi over 3 are complementary angles. Complementary angles. So complementary angles form a cofunction. Cosine 60 or cosine pi over 3 equals to sine pi over 6 or sine 30 degree. All right, so that's why we just switch those two values, right? So we get a cosine 60 is a half, sine 60 is root 3 over 2. Then here on the second quadrant, basically the values are the same, but the sign are different. So we need to remember in the first quadrant, all trig functions are positive, so all. In the second quadrant, sine and cosecant are positive, sine and cosecant positive. So that means the second value are positive. And the second value exactly same as those ones. Why? Because let's see 120 degree. 120 degree, we look at this triangle, right? We look at its reference angle. So this is true angle, 120 degree. We look at its reference angle, which is 180 minus 120, which is 60 degree. So we look at this triangle. For this triangle, the x value has a negative. The y value is still positive. So when we have a sine 60, that's a positive, the y value over the hypotenuse. So that's why sine value is still positive. So the same as the sine 60, which this is root 3 over 2. But the cosine value is negative because cosine equals adjacent over hypotenuse, which is the x-axis, which is negative. So we have negative half. Same thing here, we have negative root 2 over 2, because cosine is negative in second quadrant, but sine is positive. And this one is a similar, negative root 3 over 2, but a positive half. All right, come to this point. So this point is saying cosine 180 equals to -1, or cosine pi, right? And sine 180 or sine pi is 0. So those are important points. Oh, I think I missed this point. So cosine pi over 2 is 0. Sine pi over 2 is 1. So that's the first above the x-axis. Now let's look at the bottom semicircle. So these ones. So in the third quadrant, tangent value are positive, and also cotangent is inverse are positive. Then sine and cosine negative. So here the first one is cosine value, second one is sine value. So both negative. So we know both negative. Let's look at only one triangle. So let's look at 210. Right. So we make, well, actually we should make a triangle here. Right. The true angle we always measure from positive side of the x-axis. True angle is 210 degree. But when we talk about the values of cosine 210, we look at this triangle. So its reference angle is 210 minus 180, which is 30 degree, right? So the value itself is same as a cosine 30 and sine 30, but with negative signs. So cosine 30 is √3/2. Because in the third quadrant, because the angle is 210, so cosine 210 degree is negative √3/2. And sine is negative half. With this one, you can draw, you see that's 40, the reference angle is 45 degree, or pi over 4. So we get negative √2/2, negative √2/2. And this is the same thing, right? The angle, the reference angle will be 60 degree. So we get a cosine 60, but with a negative, so cosine, so basically this cosine 240 equals to negative cosine 60, right? And for the, so the sine also is negative in third quadrant. So also get negative √3/2, right? And in the fourth quadrant, cosine positive, but sine negative. So get the first value positive, the second value all negative. Then let's just look at one of it, right? So what is a cosine 330 degree? So look at this triangle. This angle is 360 minus 330. So the reference angle is 30 degree. So cosine 30, cosine 300, cosine is being positive in this quadrant. So cosine 330 equals to cosine 30 degree. So which is positive. Cosine 30, we know is √3/2. Sine 330. Sine 330 equals to, you see, opposite over hypotenuse. But opposite, the y value is negative, but the x value is positive. That's why cosine is positive. Sine is negative. So sine 330 degree equals to negative sine 30 degree, which is negative half. Similarly, we get a cosine 315 equals √2/2, and sine over 315 equals negative 2/2. And cosine 300 equals to cosine 60. Cosine 60 is a half. Sine 300 equals to negative sine 30, which is negative square root of 3/2. And this bottom angle, so the angle is 270. And in radian form, that's 3 pi over 2. So cosine 270 is 0. Sine 270 is negative 1. Okay. Well, let's see the angle. The angle for each one of them, you just multiply by 180 divided by pi. Now let's see this one. All right, so we need to remember the trig values being positive or negative. So sine values being positive in the first quadrant in the second quadrant. Why? Think about triangle here, right? The angle sine of this angle equals the opposite of hypotenuse. So opposite is positive, so that's positive. Think about the triangle here, represent angle is here. Opposite over hypotenuse, opposite is positive. That's why sine is positive in first quadrant, second quadrant. Now let's say B. B, in first quadrant, everyone is positive. Okay, so we just put the first quadrant positive for everyone. Everyone is positive in first quadrant. And cosine is positive in the fourth quadrant as well. Why? Because the adjacent is the x value, right? The reference angle is here. Adjacent over hypotenuse, both positive. So first and fourth quadrant to be positive for cosine. And cosecant equals to 1 over sine. Right, 1 over sine. So it means it has the same sign as the sine. So that's positive in the second quadrant as well. Cotangent is 1 over tangent. So wherever tangent is positive, cotangent is positive. Well, that's in first quadrant and third quadrant. Now let's fill in this table. Okay, important to remember. So sine 0 is 0. Sine pi over 6, which is sine 30, half. Sine pi over 4, which is sine 45, root 2 over 2. Sine pi over 3, which is 60. You can write it on the side to remind yourself in degree form. Okay. Then sine 60 is root 3 over 2. Sine pi over 2, beautiful value, 1. So we see 0, half, 1, right, through rational numbers. Cosine 0 is 1. Cosine pi over 6, 3 over 2. Cosine pi over 4, root 2 over 2. Cosine 60, half. Cosine pi over 2, 0. Tangent 0, 0. So tangent 0 basically equals to sine 0 divided by cosine 0. Right? Sine 0 is 0, cosine 0 is 1, 0 divided by 1 is 0. And tangent pi over 6, the half divided by root 3 over 2. If we rationalize, so we get root 3 over 3, right? You can use a half divided by, because sine divided by cosine, divided by root 3 over 2. That's a half multiplied by 2 over root 3. So that's 1 over root 3. But we want to rationalize the denominator. So we multiply root 3 over root 3. So get root 3 over 3. Right? Tangent pi over 4, you see the sine value is and the cosine value is the same. So tangent 45 or tangent pi over 4 is 1. Tangent pi over 3, we use root 3 over 2 divided by half. And that's just root 3. Tangent pi over 2, 1 divided by 0. In mathematics, we never divide by 0. So we say this is undefined. Not defined. Cosecant is 1 over sine. So we just flip the numerator and denominator for sine. If we flip, you see sine 0 is 0 divided by 1, right? If we flip, we have 1 divided by 0, which is not defined. So we just say undefined. Cosecant pi over 6, we just flip sine, right? Get 2 over 1, which is a 2. Cosecant of pi over 4, we just flip this 2. So we get square root of 2. Right, because if we flip, we get 2 radical 2. Multiply by radical 2, divided by radical 2. Then the denominator we have 2. Then simplify 2 over 2, so that's square root of 2. cosecant pi over 3, we'll just divide this one with this one. Cosecant is 1 over sine, right? 1 over sine, which is 2 over root 3. We'll multiply root 3. So we get 2 radical 3 over 3. Radical 3 over 3, right? Because the cosecant pi over 2 is same as 1, because 1 over 1 is 1. Secant is 1 over cosine. Okay, 1 over cosine. So 1 over 1 is 1. 2 over radical 3, that's a 2 radical 3 over 3. Then cosecant of pi over 4, so this is still root 2, right? Because we have 2 is 1 over cosine. 1 over cosine is 2 over radical 2. So good. So the 1 over cosine is a 2 over radical 2. We simplified radical 2. Now secant pi over 3, that's 2 over 1. So it's a 2. 0 over 1, 0. Cotangent is 1 over tangent. Well, 1 over 0 is undefined, right? 3 radical 3, we can simplify. That's radical 3. 1 over 1 is 1. 1 over radical 3 is radical 3 over 3. Then undefined, so cotangent we can think as a cosine over sine. Cosine pi over 2 is 0. Sine pi over 2 is 1. 0 divided by 1, that's 0. Okay, so that finished this table. Okay, number 4. Let's draw these two special right triangles. Right triangles, right? Because one angle is 90. So 45, 45, we have a isosceles right triangle. The two legs have the same length. So if this is 1, this is 1. And of course, this is square root of 1 plus 1, which is square root 2. So that's a ratio. So ratio is 1 to 1 to square root 2 ratio. Or some of you like to use x, that's fine. That's x over x, square root 2 of x. And this one we have. So one angle is a 30 degree, the other one is a 60 degree. Right? If this is 1, hypotenuse is 2, and this will be root 3. So it's 1 to root 3 to 2 relationship. If we want to carry x in it, that's fine too. That's it. That's all the recitation 8.